Yes, students, let us start. Yes. Hello, students. Welcome to the series of organic chemistry lectures. Dear students, today we are going to learn important questions from JAM 2018 organic chemistry questions. Dear students, for your practice, I made these questions as a question paper so that I am giving this link to practice this test below the video of this description. You can click on that link and you can practice on your own this test in your phone or computer for number of time, and you can see the score soon after completion of this test. Let us see the question paper. Yes, students, as you are aware about this test, there will be three sections in this JAM. So section A consists of multiple choice questions, that is 1 to 10, and each question carries 1 mark, and there will be 1/3 marks will be deducted for each wrong answer. Yes, students, I have taken all multiple choice questions. Let us see the questions and we will try to answer these questions. Right, students? The major product formed in the following reaction is, what is the reaction? Simply they are taking some aryl halide, right, substituted with nitrile and this long chain alkyl nitrile. So when you add this sodium amide in liquid ammonia, what is going to happen? These alpha hydrogens which are there alpha to this nitrile are acidic. So these, among these two hydrogens, one hydrogen will be taken up by this sodium amide to make here carbanion. C minus will be formed here. This C minus will be attacked onto this carbon and chlorine will be eliminated to give, yes, substituted to give what? Cyclized compound. How many carbons are there? 1, 2, 3. Yes, 1, 2, 3 carbons are there. Nitrile will be as it is. So the option number C is correct option, students. Next, the compound that contains the most acidic hydrogen is, as you know, the hybridization. Based on the hybridization, you can say which is more acidic. What is the hybridization in this? sp2, here sp, here sp2 and sp2, here sp3. As we know, sp3 is less acidic than sp2 than sp, or sp hybridized carbon is more acidic than sp2 than sp3. So among these four options, which is sp hybridized carbon? Yes, B. Option B is acidic carbon or acidic hydrogen. So the option B is correct option, students. So it can give H plus and it can be C minus because it is sp hybridized molecule. Next, question number 7. The C2 epimer of D-glucose is, yes, students, as you know, the 8 carbohydrates, if you write in a linear form, yes, so what are they? All altrics gladly make gums in their gallon tons. Yes, so what is the D-glucose? Yes, CHO. Yes, right side, left side. So the right side carbon, which is hydroxy, is at the right side or on C2 carbon, will be left side in D-mannose. So option A is correct option, students. Yes. Next, section consists of multiple choice questions, that is from 11 to 30. It will carry, each question carries 2 marks and there will be 2/3 marks will be deducted for each wrong answer. Yes, students, so each question the option is only one option you have to choose. Let us see the options. The correct order of stability for the following carbocations is, irrespective of these answers, what you can think? Yes, tertiary carbocation is more stable than secondary than primary. Yes, so among these three options, yes, among these three options, all are tertiary carbocations. Then what it is? Allylic carbocation. And the most important one is benzylic and allylic. Benzylic carbocation, when there is a tie-up between tertiary and benzylic tertiary carbocation. So benzylic, this is tertiary carbocation, at the same time this is benzylic carbocation. Benzylic tertiary carbocation is more stable. Let us see the options. So B and C both are showing one is more stable, right? Next, what it could be? Yes, tertiary carbocation. So 1 followed by 3. So C is looks to be the correct answer. Next 4. Yes, when it comes to this is, though it is tertiary carbocation, because of this bridge it is not stable. It is highly strained molecule, so it is not stable carbocation. So among 2 and 4, which is more stable? Allylic carbocation. Because of this hyper resonance, it is more stable. So 4 is more stable than 2. That is C. Option C is correct option, students. Yes. So option 1 is more stable. That is benzylic carbocation followed by tertiary carbocation followed by allylic carbocation followed by this option 2. Yes, students. So option C is correct option, students. Next. Question number 18. Among the dimethyl cyclohexanes, which one can be obtained in enantiomer pure form? Yes, students. Enantiomer pure form. How to get it? Yes, what it is? Both are towards downside, so it is cis. Yes, 1,2-cis dimethyl cyclohexane. When you have 1,2-cis cyclohexane, there is a chance of 1,2 trans also. Yes, so you are not going to get this enantiomer pure form. Yes, what about this? This is the trans. This is a 1,2 trans, where if you draw the symmetry line, it will be, one will be above the plane, another one will be below the plane. So it is going to be have only one isomer. Yes, students. So it is going to be one isomer, isn't it? So when it comes to this, it is going to be have symmetry, so there will be no question of one isomer. Yes, so the option number 18, question number 18, option A is correct option, students. Next. So when it comes to D, yes, plane of symmetry is there, you can cut like this. Yes, so when it comes to this 1, 2, it is also cis. So among the dimethyl cyclohexanes, which one can be obtained in enantiomer pure form? This can be obtained in enantiomeric pure form. Question number 18, option A is correct option, students. Next. Yes, this is well known example, very simple, straightforward question. That is, the major product formed in the following reaction is, this is chloroform and sodium ethoxide. What do you remember? What do you get? Yes, Reamer-Teamer reaction. Reamer-Teamer reaction, pyrrole in presence of sodium ethoxide and chloroform. What it is going to give? Yes, 3-chloropyridine. What is going to happen? This, the intermediate, what it is, carbene is going to form here like this, and the ring is going to be opened up to give this 3-chloropyridine. Option C is correct option, students. Next. The product X in the following reaction sequence is, so it is going to have 3 reactions. That is step 1 in titanium chloride zinc copper coupling. What is going to have? Yes, Wittig type reaction it is going to take place, and it is going to give double bond. This side also 5-membered ring. So both oxygen is going to be taken up by this zinc, and it is going to form this bridge double bond. When you add cold alkaline KMnO4, it is going to form dihydroxy compound. Yes, students, 1,2-dihydroxy compounds is going to be formed. When you add sulfuric acid, then it undergoes pinacol-pinacalone rearrangement to give this D. Option D, students. Yes. Next. Option D is correct option, students. Next. The major product formed in the following reaction is, what is the reaction? Yes, diene and dienophile. When you treat in presence of thermal Diels-Alder reaction conditions, it is going to form this adduct. So it is, this methylene group will be above and these two esters will be below the plane because of steric factors. So this adduct is going to form as a major compound. Yes, students. 21. C is correct option, students. Next. The major product Y and Z in the following reaction sequence are, question number 22. What is this? Aniline. Yes. So ethyl acrylate. What we are going to get when you treat aniline with ethyl acrylate? Michael addition. Michael addition is going to form 1,4 addition. So this is going to react with this, and this double bond comes here. So it is going to react with another bond. So Y is going to be this B. So what is going to happen when we are adding sodium hydroxide, then acid hydrolysis? So this diesters what is the carbon chain? 1, 2, 3, 4, 5, 6, 7. So since it is more than 5 carbons, diesters having alpha hydrogens in presence of base undergoes what is the reaction? Dickmann condensation. So in presence of base, it is going to abstract this proton and it is going to attack onto this. It loses ethanol. Yes, so this carbonyl compound and this ester will be hydrolyzed in presence of base, followed by the acid which is going to have, and then what they are doing, heating. Upon heating, it is going to lose carbon dioxide to cyclized ketone. Yes students, so the option number B, Y equal to this diester and this is cyclized. Option number B is correct option students. Let us submit B. Yes, the correct order of carbonyl stretching frequencies for the following compounds is, so the more the double bond nature of oxygen and carbon, that carbon or that CO going to have more stretching. Yes, more stretching. So it is electron withdrawing group. This is also resonance, but this is electron withdrawing group. So it is not going to allow to polarize towards oxygen. It is not going to polarize towards oxygen. So this compound is going to have more double bond character. So its stretch is going to be strong. Yes, so stretching frequency for the following compound is, so one is going to have highest stretching frequency. That means the option which is having C and D. Next follows this ester. Yes students, so ester it is not going to allow because it is positively a positive electron donating group here, but because of this ester, anyhow it is going to have double bond. Even if it gives this lone pair to form this, it is going to have double bond character more. So 1 followed by 2 is going to have highest stretch. Then what about this? Yes, this aldehyde, when it comes to this in a dimethyl, because of this lone pair availability, it is going to have enolization is going to take place. Enol, yes, imine is going to be formed by these 3 compounds. So the nature of this carbonyl CO is going to be C single bond O. Yes students, so that is why 3 is going to have less stretching frequency. So the option number D is correct option students. Next, yes, this is straightforward question. The sequence of 3 steps involved in the following conversion is, so benzene to isopropyl and 1, 2, 3 propyl benzene. Yes, meta propyl cumene, n propyl cumene is going to be prepared. When you treat this benzene with 1, 2, 3 this propyl chloride in presence of aluminum chloride, that reaction is going to be Friedel-Crafts reaction. But in presence of aluminum chloride, if you do simple Friedel-Crafts reaction, it is going to give this cumene. That isomerization takes place to give cumene ring. So first step, what I have to be done? So if I prepare this cumene first, no doubt I can prepare cumene. Then if I do the alkylation, this cumene or this alkyl group is ortho and para directing group, but it is at meta directing. So what to do is, first let us take propionyl chloride, benzene plus propionyl chloride gives, yes, estophenone, propiophenone. So do Friedel-Crafts acylation. Yes students, when you do Friedel-Crafts acylation, it is going to have this carbonyl compound propiophenone. So upon this propiophenone, it is electron withdrawing group. When you do alkylation, it is meta directing group. So Friedel-Crafts alkylation, this propyl chloride goes to this meta direction. So first propionyl chloride, then followed by propyl chloride in presence of aluminum chloride. Then this double bond can be reduced by Clemmensen reduction or Wolff-Kishner reduction to give this compound. So the option number B is correct option students. Yes, so let us choose option number B. Next, yes students, section B, as I said, there will be 3 sections. Section B is multiple select questions. That means you have to choose more than one option. Yes, So usually 2 options are correct, but sometimes even you have to choose more than 1 also, more than 2 also. What is the answer? Yes, let us see. Pick more than 1 options, no negative and no partial marking provision. That means even if you choose wrong answer, there is no negative marking. But if you choose only 1 answer, you will not get any marks. There is no partial marks, and each question carries 2 marks, students. Yes, next. On reaction with sodium nitrate and HCl, which of the following amino alcohol will yield compound P? This is compound P. What it is? So it is going to be aldehyde is downward and this is upward. So transaldehyde, trans 1,3 transaldehyde we are expecting. Yes. So transaldehyde, when you do this amine with sodium nitrate HCl, what we are going to get? Diazotization, N2Cl is going to be formed. When it loses, so trans SN2 take place. Yes, trans. What is there in this molecule? Trans. This is the hydrogen is trans to this leaving. If it forms N2Cl, when it goes off, hydrogen is trans. So hydrogen is going to form here. In this case, there is no question of this aldehyde formation. Yes, students. So next, see this. So what is going to have? This is downward. Yes, amine is downward, no problem. So what is there? Downward means it is going to have diazotization, and when it goes off, yes, what is the trans group here? This is the trans group. This is the trans group. Yes, it is downward, it is upward. So it is going to attack from here. Yes. So this carbon, so this is going to have, what is this? It is plus charge, and this O comes here, and this CHO is going to be downward, and this is going to form 5-membered, and downward means dotted lines. So B is going to form our compound. Yes, one option is correct. Next, C. Let us see. C, is it? So this is downward, no problem. This is upward. So when it goes out, same chemistry is going to form here. It is going to attack from here, right? So what is happening? No doubt whether it is this side or this side, it is going to form carbonyl compound. But this carbon, which is going to react with this carbon, is downward. So this is also is going to give. When it comes to here, this hydroxy has to become here, and in this case we are going to form epoxide. So this is not going to be correct answer. So question number 35, option B and C, both options are correct options, students. Next. So it is theory based. The correct statement or statements about carbene is or are. Carbene is a neutral species. Let us write carbene. C, hydrogen, carbene. Yes, dichlorocarbene. Yes, difluorocarbene. But let us take carbene. C, CH, and there will be 2 lone pair. Yes, 1 lone pair electron or 2 electrons will be there. So this carbene is a neutral species. So let us write A is correct, right? Carbene is an intermediate in the Curtius rearrangement. Isocyanate is the intermediate. It is not the carbene. Carbene is not going to be formed in the Curtius rearrangement. Carbene can insert into both sigma and pi bonds. Yes, students, it can insert both sigma and pi bonds. So option C also is correct option, students. Next, the compounds that shows positive haloform test is given by methyl ketones. Let us see methyl ketone. This is methyl ketone. Is it methyl ketone? No, this is ester. So A and B are correct option, students. Next, tetrapeptides that give the following product on reaction with Sanger's reagent followed by hydrolysis is R. So Sanger's reagent, what is Sanger's reagent? This 2,4 dinitro phenylbenzene. Yes, fluorobenzene, 2,4 dinitro fluorobenzene. Here fluorine will be here. So when you react with amino acid, the compound which is having amine group here is going to form this amine or aniline type. So what is this molecule? What is this? So this is alanine. What is there the first compound in this alanine? Yes, D is having alanine. and A also is having alanine. So this is the Sanger test what we are going to get. So options A and D are correct options, students. Next, among the following section C, numerical answer type, that is question 41 to 50 carry 1 mark each, no negative mark. Yes, students. So it is going to give only 1 mark and there is no question, but you have to write only the number. You should not write TWO2 ONE1 like that. Yes, among the following hydrocarbons, how many of them would give rise to 3 groups of proton NMR peaks with 2:2:3 integration ratio? What is the ratio here? So this 1, 2, 3. Yes, this is 1, 2, 3. How many signals you will get? 1, 2, 3. Yes, 1, 2, 3. Same signals. So this is going to have 6 protons. This is going to have 2 to 4 protons. This is going to have 4 protons. So 1, 2, 2, 3. Here 1, 2. There is no question. This is going to have different. So it will have 3, 1, 2, 3. But the ratio is not matching. So it is not going to have this 2:2:3 integration ratio. When it comes to this, yes, 1, 2 and 3. 1, 2, 3. How many protons are there? 3 and 3. 6 protons. 2, 2, 4. 4 protons. And this 1, 2 and this 1, 2. Same peak you will get. So that means 2:2:3 and 2:2:3. So two compounds, that is this compound and this compound, is going to have to show 2:2:3 integration ratio. So just type 2. Yes, students. Next, the number of stereoisomers possible for the following compound is, since it is having only OH and OH diol and it is symmetric, what is the, like if you remember tartaric acid, how many isomers are going to be formed in tartaric acid? Yes, how many? 3. So here also just based on that, because one isomer is going to be meso compound, so because of symmetry it is going to be meso compound, it is going to have 3 isomers, right? The number of hydrogen bonds present in a guanine cytosine base pair is, so guanine and cytosine, what is this? Tribasic compound, so it is going to be 3. Next, elemental analysis of an organic compound containing CH and O, carbon, hydrogen and oxygen, gives percentage composition. Carbon is having 39.9% and hydrogen is 6.7%. If the molecular weight of the compound is 180, the number of carbon atoms present in the molecule is, if you ask me straightforward answer, yes, I will round off this to 40, and 40 means if a compound is having for 100, it is going to have 40, then what is the percentage of this carbon? Yes, 40, 100 is 40, 180 is how much? So what I will do, 180 into just cross multiplication, 100 is going to have 40, 180 is going to have how much? 180 into 40 by 100. Yes, 0, 0 cancel, 40 cancel, 18 into 4, how much it is? 72. Yes, 72. The molecular weight of carbon is 72. How many carbons are going to have? So 72 divided by 12. 72 divided by 12. What is the answer? 6. Yes, students, it is 6. Answer is 6. Next. Yes, the number of compounds having S configuration among the following is. So you may confuse, it may not be the chiral compound. Yes, allenes are chiral compounds. This is allene. Remember like this. Allenes are chiral compounds. When you look from this side, what is the numbering? Let us give the numbering. Yes, let us write 1. Yes, it is down. Hydrogen is down already. 1. And this, when it comes to here, it is going to be top. So this is 1. It is going to have 1, 2 and 3. It is S configuration. No doubt this is S. Yes, it is no question. So in this case also hydrogen is down, right, friends? So give the numbering. This is 1 and 2, 3. S configuration. Yes. So hydrogen is left side. You have to bring this hydrogen towards down. But however, let us write 1, 2, 3. 1, 2, 3. It is S configuration, right? When you write to this compound, what this is S configuration it is showing. But you have to bring this hydrogen back. So double exchange, it is going to show R configuration. This is not going to be the S compound. It is going to be what is this? R configuration. Let us see this. It is above the plane. So among these, what is this? Yes, triple bond. Triple bond gives priority 1, then 2 and 3. So it is showing R, but hydrogen is above the plane. When you bring back or exchange, it is going to have S configuration. This is S, this is S, this is S. It is R. And when it comes here, what is this? Yes, this side when you move here, it is double bond. So 1 here, 2 here and 3. 1, 2, 3. It is R now, but you have to bring hydrogen back. So it is going to have S. So 1, 2, 3, 4. 4 compounds are going to be S configuration. Let us write 4. Yes, students. Yes, we have completed all organic chemistry based questions. Let us submit. Yes, students, you can view the score also. Yes, students, organic chemistry questions carries 34 marks in JAM. Congratulations, students. You got all questions. Answers are correct. Yes, what are the answers? The major product formed in the following reaction is option C. Yes, this is acidic hydrogen. Yes, ethylene. This is mannose, and this is order of carbocations stability. Yes, what it is? Among the dimethyl cyclohexanes, enantiomer pure compound is A. Yes, Remer-Temer reaction. This is yes. So pinacol rearrangement. It is Diels order reaction. This is Michael addition followed by Dickman condensation. Yes, this is IR based question. Yes, Friedel-Crafts acylation followed by alkylation. Yes, this is diazotization and SN2 reaction. Yes, carbon theory based question. This is straightforward. Methyl ketones are going to show this positive haloform test, and this alanine is going to form this product after Sanger's reagent followed by hydrolysis. Then what is this? 43 NMR peaks. How many are there? 2. Yes. Next, what is this? Same, based on tartaric acid. You may remember this tartaric acid. It will have 3 isomers. Yes. And question 45, number of hydrogen bonds. It is guanine and cytosine tribasic. So 3. And question 54, it is 6. That is, it is nothing but 180 is glucose molecule C6H12O6. It is going to have 180 molecular weight. Straightforward also you can give the answer if you remember. And this is RS configuration. You have to be careful while doing this type of questions. So allenes will show this configuration, and these two allenes are stereoisomers. Yes, students. Congratulations, students. So this is how you can practice this question paper in your phone or computer. I am giving the link below this video description. Thank you, students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and